Hi everyone, today we are going to be talking about moles. Now students often find this tricky, but stick with me and we will get it sorted. I am going to split this video into two parts. Part one is the basics and part two we are using moles to balance equations. Now before we start, this will not make a lot of sense if you don't understand relative atomic mass and relative formula mass. So if that's something you're not sure on, pause this right now, go find out and then come back. I'm going to start with a seemingly unrelated question. Why don't we measure distances between stars using miles? Well, it's because space is too big. The numbers would be ridiculously large. So we don't use miles, we use something like light years or parsecs. They were invented to talk about travelling in space under such huge distances. Now, what if I asked you this question? How many atoms are there in 5 grams of carbon? So we suffer from the same problem. It's such a ridiculously large number. We need something that expresses these large numbers, and we have the mole. The mole expresses a ridiculously large number of atoms, so we don't need to talk about billions and trillions and trillions. 1 mole of any substance is 6.02 times 10 to the 23 atoms. Okay, so 1 mole of hydrogen contains 6.02 times 10 to the 23 atoms. Now let me ask you something. Do you think that 6.02 times 10 to the 23 atoms of carbon is going to weigh the same as 6.02 times 10 to the 23 atoms of hydrogen? What do you think? Yes or no? The answer is no. And the reason is because a hydrogen atom weighs 1 and a carbon atom weighs 12. There are no units. So 1 mole of carbon is 12 times more than 1 mole of hydrogen. 6.02 times 10 to the 3 atoms of hydrogen is 12 times less than 6.02 times 10 to the 23 atoms of carbon. So that many atoms of hydrogen has a mass of 1 gram. So how many grams do you think 6.02 times 10 to the 23 atoms of carbon would weigh? 12 times more. 12 grams. So what's the mass of 6.02 times 10 to the 23 atoms of lithium? Well, look at it on the periodic table. It says 6.941. Let's round that up to 7. What is the mass of 1 mole of beryllium? 9. 40 grams of calcium would contain how many moles? 40 grams of calcium. Look at calcium. How many moles? That's 1 mole. How many moles would you get in 80 grams of calcium? Well, if 40 is 1, 80 must be 2. So these are some fairly simple sort of calculations. Now, when dealing with mole questions, this equation triangle can be quite useful. I don't usually like the idea of using these triangles. I think people should know how to rearrange equations, but here we go. This one's quite useful. Pause the video now, scribble it down, and then you can have a go at some of the questions on the next slide. Just note that if you are talking about individual atoms, we'd be talking about relative atomic mass. If it's molecules we're looking for, then it's the relative formula mass. So pause this now, jot that little triangle down, and then the slide's going to change. Try the questions. So here they are. Here's the questions. Pause the video again. Answers coming in a few seconds. Okay, there's the answers. See how you did. Hopefully you managed to get all 3 of those. So that's part 1, the basics finished. Part 2, we're going to use mole to balance equations. So we have a question here. 2 grams of hydrogen reacts with 71 grams of chlorine to make 73 grams of hydrogen chloride. Write the balanced equation. Question tells us the relative atomic mass of hydrogen is 1 and the relative atomic mass of chlorine is 35.5. So all we need to do is write out the formula and then calculate the number of moles for each chemical. So there is a point here where students might go wrong, and that is that students forget that hydrogen is diatomic and so is chlorine. That means they go round in pairs. Don't forget to put those little subscript 2's in. So there's our equation. Now we just simply have to calculate the number of moles. Use that triangle that I gave you, mass over relative formula mass. Well, the question said it wanted 2 grams of hydrogen, and the relative formula mass of hydrogen is 2. So 2 over 2 is 1. So we put that little 1 in there. Next one, chlorine. The question said it wanted 71 grams of chlorine. So that's the mass. Now divide that by the relative formula. Mass of a chlorine molecule, well, that's 2 chlorine atoms. And if chlorine's 35.5, as it is on the periodic table, then the relative formula mass of the diatomic molecule is 71. 71 over 71, that's 1. Pop the 1 in. Finally, let's have a look at HCl, hydrogen chloride, or hydrochloric acid, if you want to call it that. 73 grams the question calls for of hydrogen chloride. So it's 73 is the mass divided by a relative formula mass. Okay, what's the relative formula mass of HCl? 35.5 plus 1, that's 36.5. 73 over 36.5, that gives you 2. So we pop the 2 in. Now we don't write 1s in chemistry, it's just assumed that if there's no number next to it, it is a 1. So we can ditch those 1s and it should look like that. There's your final answer. Hopefully that makes sense. If it didn't, maybe go back, watch it again. If you think it did make sense, then have a go at this little sample questions. Answers will flash up in a few seconds. I hope that was helpful. Thanks for watching.